Hello.
Hello everyone. Today I'm going to be presenting my tech talk topic of MTT, which is extending Laplace and Z transform domains. Let's get started with it. First of all, I'm going to be a brief abstract about it. A generalization of a Dirac delta function and its family of derivatives recently proposed as a means of introducing impulses on the complex plane in Laplace and Z transform domains is shown to extend applications of bilateral Laplace and Z transforms. Transforms from two-sided signals and sequences are made possible by extending the domain of distributions to cover generalized functions of complex variables. The domains of bilateral Laplace and Z transforms are of complex variables. The domains of bilateral Laplace and Z transforms are shown to extend to two-sided exponential and fast rising functions, which without such generalizing impulses have no transform. Applications include generalized forms of sampling theorem, a new type of spatial convolution of two-sided infinite duration forcing function and sequence. Let's get started with the introduction. Generalized functions have expanded considerably the domain of existence of the Fourier transforms. Weighted spectra leading to impulses on the complex Laplace and Z transforms planes have been proposed for the exponential decomposition of finite duration signals. The decomposition of infinite duration complex exponential continuous time and discrete time signals leads in general to diverging integral and summation. Generalized Dirac delta impulse have has for objective to define transforms for a class of function which leads to integrals that are not absolutely convergent. In this paper, the distribution theoretic basis of generalization is presented, followed by properties of the new distribution and the resulting bilateral transforms. Complex domain distributions. The generalized distribution associated with Laplace transform complex domain as generalized function of a complex variable. G of s is equals to alpha plus j omega may be defined as integral along a straight line contour in the S plane, extending from S is equals to alpha minus infinite times of j to alpha S is equals to plus plus infinite alpha j of the product of G of S with testing function psi s. For the convenience, we refer to integral by the symbol integration gi of psi s, or simply and use the notation. As you're seeing, this is the formula of a complex domain distributions. The test function psi s has derivatives of any order along straight lines in the S plane going through the origin and tends to zero more rapidly than any power of S. Let's take, for example, if generalized distribution is generalized impulse of tau to S, and we have the formula over here. It's equals to J psi of 0 or 0 if alpha is equal to 0 or alpha not equal to 0. Basic properties. In the following section, in the following, a selection of basic properties of generalized distributions in the context of the continuous time domain and Laplace transforms are included due to their importance and evaluating transforms. Letting S naught is equals to psi 0 plus j omega naught, we may write as the following formula. Formula is over here, g of s is s minus s naught, comma psi of s is greater than r of s of is equals to alpha, that is equals to alpha plus j times infinite, and integration from alpha minus j infinite to alpha plus j infinite g of s minus s0 psi s ds. Letting s minus s0 as y and ds is equals to dy, we obtain the following thing. We may take it from g of y comma to psi of y plus s naught. Let me adjust this. As we're seeing product with any ordinary function, consider the product g of s into f of s. We can write it as g of s into f of s comma psi of s. So this will be the same, but we have the product, that's it. Let r is equals to 0 be a real constant. We can write it as this equals gamma of gamma is equals to 0, gamma s is equals to y, gamma of ds is equals to dy. You obtain the following function, that is equals to 1 by mod gamma from g of y to psi of y by gamma. Convolution, it's one of the basic properties in Laplace transforms of z transform or bilateral transforms. It's like denoting by g1 of s into g2 of s. The convolution of two generalized distributions with y is equals to sigma plus j omega. We may write it as I is equals to g1 of s into g2 of s comma psi of s, that is equals to integration sigma minus j infinite to sigma plus j infinite g1 of y into g2 of s minus y dy. I is equals to g1 of y integration alpha minus j omega to alpha plus j omega g2 of s minus y psi of s ds. In this, we are taking the constant to be as psi and sigma. The integral on the right being in the form of convolution with a test function belongs to the class of test functions. Differentiations. As we know about differentiations a lot, we have studied about it. From g dash of s comma psi of s, that is equal to integration of sigma integration of alpha minus j infinite to alpha plus j infinite g dash of s psi of s ds. Integrating by parts, we obtain minus of g of s comma psi dash of s. By repeated differentiation, we may get it as minus 1 whole to the power n less than g of s comma psi to the power of n of s greater than r of s is equals to alpha. Multiplication of derivative times of ordinary functions. Consider the product of g dash of s and f of s. We can write it as g dash of s into f of s comma psi of s equals to integration integration alpha minus j omega j infinite to alpha plus j infinite g dash of s f of s psi of s ds. Integrating by parts, we obtain g dash of s f of s psi s, that equals to minus of g of s comma f dash of s psi s. Discrete time domain. The distribution. The distribution discrete type domain. The distribution of g of z may be defined as the value of integral denoted by I of g of psi of z of its product with a test function of psi of z. Symbolically, we can write it as Ig of psi of z is equals to g of z comma psi of z, which is less than mod z equals r when mod z is equals to r, where the contour of integration is a circle of radius r centered at the origin in the z plane. Similar properties to those of the continuous time domain are encountered in the discrete time domain. Application of discrete time generalized impulses. The discrete time domain generalized impulse will be denoted by the symbol of it's the symbol of significance of psi minus r z and is equivalent to tau of z minus 1. As we are seeing this formula of it, when x of z is analytic at z is equals to 1, then okay. So r is equals to 1, r not equals to 1. Differential and difference equations with two-sided forcing functions. In what follows, the steady state solution of differential and difference equations are evaluated with non-casual infinite duration two-sided functions, that is extending from minus infinite to plus infinite. Let's take this an example. To find the steady state solution of differential equation y to the power m plus 3y to the power n plus 3y to the power r plus y is equals to 2t plus 8. Applying the Laplace transforms, we may, by applying it in the form of s cube plus 3s square plus 3s plus 1 into y of s equals minus 4 pi tau of s plus 16 pi tau of s. We may find the value. Oh, sorry. We may find the value of y of t is equals to 2t plus 2 by using the differential and difference equation, the two-sided forcing functions. Generalized sampling impulse train. Generalized sampling impulse trains which grow or decay exponentially or as a special case are the common uniform constant level train can be transformed by the extended bilateral Laplace and Z transforms. As we are seeing this graph, the graph goes up towards the higher side, showing a straight line, which is possible since now the Laplace transform of the impulse train exists. Similarly, sampling by a growing or decaying impulse train may be affecting in the S-plane. This figure shows the Laplace transform of an exponentially rising impulse train. Table 1, extended Laplace transforms of basic functions. Okay, we got 1 to be as 2 pi to of s, e of at is equals to 2 pi of s minus 1, s minus a, cos hat to be of pi of tau of s minus a plus tau of s plus a, cos j beta t to be as pi of alpha omega minus beta plus tau of omega plus beta, u of t to be as 1 by s plus pi of tau of s, e to the power a ut to be as 1 by s minus a plus pi tau of s minus a, e power a cos beta t to be as pi tau of s minus alpha plus j beta plus tau of s minus alpha minus j beta e power at cos beta t ut and t to the power n t to the power n of ut is almost all they have same of them. Extended Z transforms of basic sequences. Okay, x to the power n and extended Z transform x capital X to the power Z capital X of Z 1 2 pi psi of Z e to the power n to be as 2 pi psi of Z by a u into n should be as 1 minus Z inverse plus pi to psi of Z a to the power n u into n to be as 1 by 1 minus a into z inverse plus pi psi of a z by a, and we got n to the power n to the power r, u by un, and n to the power r. Okay, this was my tech talk of MTT. Thank you everyone. Hope you have a great day.